All right, in this lesson, we're going to be looking at some different ways to solve what's called a system of equations. A system of equation is when we have more than one equation and we're looking for a common solution or common set of solutions. And so here we have two equations, x minus 2y equals negative 2 and x plus 2y equals negative 6. And so our goal here is to figure out what coordinate, so an x and a y value, that would make both of these equations true. So we're looking for a single coordinate that would work in both of these equations. Now, one thing you might notice is these are not in slope-intercept form. Now, some teachers would have you rewrite each of them in slope-intercept form and then graph it, because it is a little bit easier to graph in slope-intercept form. But the problem is if you make a mistake converting to slope-intercept form, well, that means your answer is going to be wrong. So instead, I'm going to show you a different method, and that's by finding the intercepts, because these, being in standard form, it makes it really easy to find something, or to find the x and y intercepts. So let's start with this first one. This first one, I'm going to put a little red dot here so you know what graph I'm referring to. But to find the x-intercept, imagine, if you would, that we covered up a term. So now you guys have fingers, so you can do this on your own on your own notes, and you can cover this up with your finger. Now again, we're trying to find the x-intercept, so we cover up the y value. So that way all we see is the x. And if you notice, we get the statement x equals negative 2. So the x-intercept is at negative 2. And to find the y-intercept, guess what we're going to do? We are going to cover up the x term. Now don't accidentally cover up that minus, that's important. Now, notice this time we don't have x equals negative 2 like we had before, we have negative 2y equals negative 2. Well, if I wanted to solve that, I would divide both sides by negative 2. And doing so means that we would have a y-intercept, because negative 2 divided by negative 2 would be a positive 1. So the x-intercept would be at negative 2, the y-intercept would be a positive 1. So let's graph those. Negative 2, positive 1. And we're going to connect these with the line. All right, so that would be the shape of our graph. Now let's go to the other one. The other one, I'll do this one in purple. We're going to do the same exact process. To find the x-intercept, we would cover up the y. And I get the statement, there's nothing I have to simplify there. I get the statement x equals negative 6, so the x-intercept is at negative 6. So then to find the y-intercept, we cover up the x. And now I have the statement 2y equals negative 6, so we need to solve for y. So if I divide by 2, I get the y-intercept is negative 3. So we're going to graph. Now this is not a coordinate. Negative 6, negative 3 is not a coordinate. That's another mistake students make. These are two separate coordinates. One is the x-intercept, so where it intersects the x-axis. And the other one's the y-intercept, where it intersects the y-axis, is at negative 3. And then I connect these. All right, so now we're looking for what is the intersection. Where do these two lines intersect at? Because where they intersect at, that's the solution. Now, before we did this, which is trying to find just the x value. Well, now we want to find both an x and a y value. So the intersection point is a coordinate. It's a coordinate where x is negative 5, or negative 4 rather, and y is negative 1. So that would be your solution. Negative 4, negative 1. So that's how we would solve it, by graphing. Now, graphing is not the best way to do it. In fact, it's probably going to be the least used method to solve a system of equations, because they're not always going to intersect at nice little grid lines. And even if they did, if our graph, when we go to graph it, isn't very accurate and we're off just a little bit, it's going to make it so maybe our answer will be wrong. So we really don't like to graph to solve a system of equations. So let's look at some other options. So one of the options is called substitution. So the steps are over here on the right. So to solve a system by substitution, the first step is to isolate the loneliest variable in one equation. What do I mean by that? When we look at the variables, we have a negative 3x, a y, a negative 7x, and a 5y. The loneliest one here is the y. It is not paired up with a partner to dance, or whatever the case might be. So I'm going to solve for y. So to solve for y, to get the y by itself, I would add 3x to both sides. So I'm just going to rewrite this to get the y by itself to say y equals, if I add 3x to both sides, it'd become a positive 3x, and that minus 2 is a negative 2. Okay, so that's the first step. The second step is we're going to substitute into the other equation, because here's what the statement is saying. It's saying that y is 3x minus 2. So I'm going to take what y is, 3x minus 2, and I'm going to put it in for y, because that's what we're saying y is. Y is 3x minus 2. So in the other equation, we're going to write this as negative 7x plus 5, and what y is, we're going to put that in. Okay, so that's step 2, substitute in the other equation. So now the next step is we're going to solve that equation for the first variable. So we're going to solve for x. Okay, so we're going to find the first variable here. In this case, it's x. So whatever variable we have in this equation that I have in green, that's what we're going to start to solve for. So I'm going to start by distributing the 5 through. Now I recognize that we can combine like terms. So negative 7x plus 15x is 8x. And I'm going to also add 10 to both sides, just to do 2 steps in one here. So I'd have 14 plus 10, or 24. So if I divide by 8, we would get x equals 3. So remember, what we're looking to find is a coordinate. So we just found that our x value is 3, but I still need to find what my y value would be. So that's our step 4. So step 4 is substitute in either equation to solve for the second variable. So now we know that x equals 3, and I can substitute that in into any one of these 3 equations. So I'm going to use this one. So say y equals 3 times my x value, which is 3, minus 2. Or 3 times 3 is 9, 9 minus 2 is 7. So we get y equals 7. So the answer is a coordinate when x equals 3, y is 7. So we're going to always follow these 4 steps anytime we want to use substitution as our method. So to practice, I want you guys to practice this one by using substitution just like we did in the previous one. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so let's start with the first step. The first step is to find the loneliest variable. Here's my loneliest variable. So I'm going to solve for x, meaning I want to get rid of the minus 3y, so I'm going to add that to both sides. And when I add 3y to the other side, we would get x equals a positive 3y, and that would be a positive 15. All right, so now we're going to take what x equals, a 3y plus 5, and put that in for x, because we're saying x is 3y plus 5, x is 3y plus 15. So we're going to put that in for x in the other equation. So now I have the statement, negative 4 times the quantity, 3y plus 15, and then it'll be minus 3y equals 15. All right, so now the next step is to solve for this variable. So the variable I'm going to solve for is y. So I'm going to start by distributing the 4 through. So it'll be negative 12y. Negative 4 times 15 would be negative 60. And then minus 3y equals 15 would stay the same. Now I want to combine like terms. Now negative 12y and 3y, they're on the same side of the equation. So don't add 3y because, again, they're combined. They're already on the same side of the equation, so we can combine those like terms. So negative 12y plus negative 3y, so combining those would be negative 15y. But what I want to do is I want to add 60 to both sides to get the numbers that don't have a variable together on the same side. So now I have the statement negative 15y equals 75. Divide by negative 15. Might need to use a calculator, but you'd end up with y equals negative 5. All right, so we just found what y is. So now we're going to take and plug what y is into any of the 3 equations. I'm just going to use this one. So we'll have the statement x equals 3 times what y is, negative 5, plus 15. So obviously, 3 times negative 5 is negative 15, and negative 15 plus 15 would be 0. So our coordinate, which is a solution, is where x is 0, y is negative 5. Make sure you put them in the correct order. It's the x value first, the y value second. All right, So that's how we would solve by substitution. So we've talked about how to solve by graphing, how to solve by substitution. We're going to end, or I guess we're going to look at some special situations after this. But as far as our other type, there's only one other process, one other method we could use, and that's what's called elimination. Now for this one, I'm actually going to start with 1D. And there's a reason for that. So let's start with this one here. So for this one, what I want to do is to eliminate, I'm going to add these, my goal is to be able to add these two equations, and when I add them, get rid of one of the variables. If I just added these two without doing anything to it, negative 2x minus 3x, that's negative 5x, that's not 0. If I add the y's together, negative 2y and negative 10y, that's negative 12y, that's not 0. So we want to get rid of one of the variables. So I want to figure out, well, what could I do? What could I multiply one of the equations by so I would eliminate one of the variables? So in this first equation, if I multiplied by a negative 5, I want you to see what happens. I'm going to write that below here. So negative 5, I'm going to multiply everything by negative 5. I'm going to use those lines to help remember and not forget to multiply even the number on the very end by negative 5. So negative 5 times negative 2x, that's a positive 10x. Negative 5 times negative 2y, that would be a positive 10y. And negative 5 times negative 2, that's a positive 10. Now watch what happens when I add these together. Negative 3x plus 10x, that's 7x. Negative 10y plus 10y, that's 0. And negative 24 plus 10 would be negative 14. So see what happened when I multiplied those together, when I multiplied by negative 5, it created a positive 10y. So your goal is to pick a variable so that the values are the same but with opposite signs. Okay, so by multiplying that first equation by negative 5, it then made it so we have this, so the y's are the same, the 10s are the same, but the signs are opposite, a negative and a positive. So you always want that, where one's negative and one's positive. All right, so let's finish this out though. We're going to divide both sides by 7 now to get my answer for x. X equals negative 2. And after this, it is just like we did for substitution. I'm going to substitute what we know x to be into one of the equations. Now this is going to require a little bit of extra work because we don't have them rewritten at all. So you get to pick whichever equation that we want to use. I'm going to use this first one. I'm just going to plug in what x is. X is negative 2. We have minus 2y equals negative 2. So we just plugged what x is into the original equation, or any one of the original equations. Now when I simplify that, negative 2 times negative 2 is a positive 4. Then we'd have minus 2y equals negative 2. So now to solve for y, I would subtract 4 from both sides. And then I would divide both sides by negative 2, and I would get y equals positive 3. So my solution here would be where x is negative 2, y would be positive 3. That would be my answer. So now let's look at this previous one, the one that we skipped. So I skipped this one because I didn't want you guys to always think that this is going to be the case. This does not happen very often, but look what we have here. So we want to be able to see which of these variables I could eliminate. So look at these y's. The y's have 3's in front of them, so they have the same value. And they also have opposite signs already. So these, we could just jump right in and add them together. So if I add these together, 3x plus 4x is 7x, and 3y minus 3y is 0. Negative 24 plus a negative 25 would be negative 49. So this one we didn't have to do anything to them. We just had to add them together to get rid of the y's. But again, that does not happen very often. All right, so now to solve for x, I would just divide both sides by 7. So I get the statement, x equals negative 7. So then I'm going to plug that into either one of the original equations. So let's do it let's just go ahead and do it. The first one again, so we'd have 3 times what x is, negative 7, plus 3y equals negative 24. So when I go to simplify this, we'd have negative 21 plus 3y equals negative 24. If I add, If I add 21 to both sides, negative 24 plus 21 is negative 3. And then if I divide by 3, we get y equals negative 1. So we have our two values. We have our x and our y. So the solution would be the x first, negative 7, the y second, negative 1. So that would be your coordinate for your solution. All right, so you're going to do the next one on your own. The next one is more like the one that we started here. Okay, so that's one. So the one that you're going to do on your own, you're going to have to start by trying to figure out, well, which variable do you want to get rid of? Do you want to get rid of the x's? Do you want to get rid of the y's? To figure that out, look at the smallest term for your x and your smallest y. So here we have 2x, here we have 2x, here we have 4y. Those will be our smallest between the 2, 10, 6, and 4. And so look to see, well, is there a number I can multiply 2 by to get 10? Or is there a number I can multiply 4 by to get 6? So hopefully you should see that. So whatever number that would be, that's the number you want to use. So why don't you guys go ahead and pause this video, see if you can't figure it out on your own. But if not, just hold on a second, but otherwise pause and hit play when you're ready to check your answer. All right, let's see how you did. So hopefully you recognize that we're going to multiply this second one by 5 this time. When you do that, you get a positive 10x plus 20y equals 40. So we multiply every single term by 5. You need to see that other equation, so I'm going to erase this. All right, so now I want to look at these two. These are the two that I'm going to add together. Okay, so we changed that second once, but we haven't done anything with that first one. So I'm going to add those two together. So when I do that, negative 10x plus 10x is 0 x's, so we don't have any x's. Negative 6y plus 20y, that's 14y. And 30 plus 40 would be 70. If I divide both sides by 14, we end up getting 5 as our answer. So that's our answer for y. So now what I'm going to do is I'm going to plug that in into either one of the original equations. Let's see, which one would be easier? I'm going to do it in the first one. So I put 5 in there for y. So when I simplify this, negative 10x, negative 6 times 5 would be negative 30. Now I would add 30 to both sides. I get negative 10x equals 60. If I divide both sides by negative 10, I get negative 6 as my answer. So the coordinate here would be the coordinate where x is negative 6. So I always start with the x. Y is second, so y is 5. So you get the coordinate negative 6, 5 would be your solution. All right. So we have some special solutions. Let's first start, because you're not always going to have linear equations that intersect. We could have linear equations that are parallel to each other. If they're parallel to each other, there's going to be no solution. So parallel lines always result in no solution. If we were to graph two lines, and let's say one line looked like this, and the other line was exactly on top of it, so they shared the same line, then they have infinite solutions. Okay, so if they have the same line when you go to graph them, then they have infinite solutions. So we're not always going to graph those. So how would that look if we solve by substitution or elimination? So both of these would combine to be the same, to have the same look. So if the variables cancel out, and you are left with a false statement. Oops, can't spell. So if you have a situation where the variables cancel out, you're left with a false statement, then there's no solution. What would that look like? Well, we'll look at some specific examples here in a minute, but What it would look like after the after the variables cancel out, you're left with the false statement, might look something like this, like 0 equals 2. That's a false statement. 0 doesn't equal 2, so then that would be no solution. So what would it look like if there are infinite solutions? If there are infinite solutions, that means the variables cancel out. And you are left with a true statement. Again, can't spell. So what does that look like if the variables were to cancel out and you're left with a true statement? That'd be like if you got 0 on the left and 0 on the right. So we have a true statement. 0 does equal 0, so then that means that if you were to graph them, they'd be the same line. So there'd be infinite solutions. So let's try that out again. We're not gonna graph these. We're gonna solve either by using substitution or elimination. So let's look at this first one. I'm gonna do with this first one, actually both of these, I prefer elimination. So if I'm ever given the choice, I'm gonna use elimination. So for this first one, I look at this, and let's say I wanted to get rid of the x's. I multiply by 2, because then we'd have a 2x and a negative 2x. But then watch what happens with the other terms, because remember, you don't just do the first term, you do all the terms. So 2 times x is 2x, but then 2 times 6 is a positive 12y, and 2 times 4 is a positive 8. So when we go to add these together, negative 2x plus 2x, well, that's 0. There's no x's. Negative 12y plus 12y, that's also 0. So the entire left side is 0, and the right side, negative 8 plus 8, is also 0. So that is a true statement. So this means that they are parallel lines, or there are infinite solutions. Or not, I'm sorry, not parallel lines, they're overlapping lines. So these are overlapping lines, so there are infinite solutions. All right, let's look at the next one. The next one, let's see, which variable do we want to get rid of? Looks like the x's would be easy to get rid of by multiplying by 2 in that second equation. So when I do that, I would get a positive 10x, a positive 12y, and a positive 30. So when I go to add this new equation with this one, because again, we don't work with the ones that we manipulated, so I'm not going to work with this one because we changed that one to be this one here. So when I add these together, negative 10x plus 10x, 0. Negative 12y plus 12y is 0, so the left side is 0. And the right side, negative 15 plus 30 is not 0, that's 15. So there is no solution here for that one. That's how we would write our answer. We would just say that there is no solution. All right, so that is the end of these notes. I know there was a lot of information here, so I want you to work on your assignment now, and good luck as you do that.